Hello Galactopians. Ever heard about DEPIN, Decentralized Physical Infrastructure Networks? Welcome to my tutorial about the Golem network. In this tutorial I want to show you how to build, deploy and use a static Three.js web app on the Golem network. After that you will have an idea about what the hell a DEPIN is. So let's dive in. If you do know Bash scripting in the Docker environment and if you are familiar with Linux or Mac OS and some Web3 concepts, this tutorial is for you. It would not take that much time to follow the slides. I try to summarize the concepts behind the Golem network as dense as possible. If you are interested in DEPINs or if you are a DevOps who is interested in what it means to use decentralized Web3 enabled infrastructure, this tutorial is something for you. So let me introduce the Golem network. First I want to give you a short definition of the Golem network. Then I want to tell something about the different roles of the participants of the network. And then we will have a look at Golem's architecture. What is the Golem network? Golem network is an open-source decentralized P2P platform where everyone can use and share each other's computing power without relying on centralized entities. It establishes a decentral marketplace for compute demands like AI and data analytics and offers its services as a decentralized physical infrastructure network, DEPIN. Participants of the Golem network offer and pay these services through the utility token GLM. In the Golem network, compute nodes can participate as a provider node or a requester node. The default implementation of the service is called Yagna. A provider shares its unused compute resources like CPU, GPU, memory and storage for requesters in exchange of the utility token GLM. The micropayment is most often executed through the Polygon network. The mainnet is used for normal paid operations. Ethereum's Holesky testnet is used for development. The Yagna service is the heart of the Golem network. Yagna establishes a peer-to-peer network between all participants, providing the communication infrastructure for the compute marketplace. The Polygon network establishes the payment infrastructure for the Golem network. Builders can store their solutions in a public image registry. They do this via a transformed Docker image which is made compatible with the Golem runtime via a specific build tool. Compute providers offer their services via the marketplace as an anonymous participant which gets selected by the Golem network if the compute needs of a requester fits with the provider's offering. I will show you the different steps which are needed to deploy a solution on the Golem network. We will build a static Node.js web application which serves a simple Three.js page and put it into a Docker image. Then we transform this Docker image to a Golem image that we can deploy it to the Golem registry. After that we will act as a requester to run this image on a provider node. We build a small Express.js web server application which serves our Three.js application and define a Docker image out of it. The Express.js app serves the content of a public folder which holds our static Three.js app and listens on all network interfaces. The source code of the Express.js application is accessible on GitHub. This simple Docker file defines our Docker image. As you can see, we expose port 8085 to the outer world. Calling the build-x docker command builds our newly defined image so that we can test it before transferring it to a Golem image. After running the container image, you can access the web app via localhost 8085. Building a Golem image out of a Docker image is easy. We just have to call the provided build tool gvmkit build from Golem and give it the name of the Docker image we have created in the last step. The gvmkit build tool not only prepares a Docker image to be used by Golem, it can also be used to deploy the new Golem image to Golem's image repository. Anyone can sign in at Golem's image registry to deploy a Golem image which then can be used by Golem's compute providers. Once the image is stored in Golem's registry, everyone can use it to let it run on one of the compute nodes provided by Golem's providers. We will now take over the role of a requester and create a compute job by using Golem's DApp runner tool. First we have to define a configuration for the compute job. First we have to define which payment network we want to use. We are doing this by setting up a Golem config YAML file where we define to use Ethereum's Goerli testnet as the payment platform. Remember that you have to fund your requester wallet first with the Yagna payment fund command. Then we define a compute job in form of an additional configuration file called base_app YAML. The tag image _ hash defines the Golem image we want to run on the network and is defined in the registry. With the two configuration files in hand, we can now try to set up our compute job. We start the Yagna service in one terminal and try to identify the app key for our requester via the command Yagna app key show requester. We have to announce to the network that we want act as a requester via the command Yagna payment init sender. Then we have to set up our requester app key via export yagna underscore appkey equals requester underscore app key, and finally start the dApp runner application. If everything was set up correctly, a compute node at the Golem network takes over the job and creates a new compute instance. You can connect it via a local HTTP proxy initiated from the local Yagna service to the remote instance by your local browser, by using the promoted URL. Let me summarize what we have learned during this lesson. Golem network provides decentralized computing power. Application registry is open for everyone. Marketplace is very intransparent. Current state feels like a technical proof of concept. Base infrastructure ready, but there are a lot of moving parts. Thank you for watching this tutorial. Don't forget to like and subscribe this channel. Have a good day.